Hello, this video is about the Pythagorean Theorem. For the Pythagorean Theorem, you must have a right triangle. Sides are a, b, hypotenuse is c, and a squared plus b squared is equal to c squared. So starting with number 1, find the hypotenuse if a is 6 and b is 5. So we're going to put a squared plus b squared equals c squared, the Pythagorean Theorem, down first. And we're going to say 6 squared plus 5 squared is equal to c squared. 6 squared is 36. 5 squared is 25. 36 plus 25 is 61. Now, this is distance, so you square root both sides, and you keep it positive. So your answer would be c is equal to the square root of 61. So for number 2, your c value is here at the x. This is a and b. So again, your Pythagorean theorem, a squared plus b squared equals c squared. 5 squared plus 4 squared is equal to x squared. Notice that I do not have the a and b in the same place as the original picture, so it does not matter which leg is a and which leg is b. So 5 squared plus 4 squared is 41. It's equal to x squared. Again, because it's distance, we get the positive square root of 41 is equal to x. So x is equal to the square root of 41. Okay. Now, number 11 here is a squared plus b squared equals c squared. X squared plus 4 squared equals 7 squared. Notice here, we don't know what c is. Okay, c is always the hypotenuse, so that means it's across from the right angle. And I always mark c. X squared plus 16 equals 49. So using your algebra skills, subtract 16 from both sides. X squared is equal to 33. So x is equal to the square root of 33. Number 12, c is 18. Again, c, that's 15. 15 squared plus x squared equals 18 squared. That's 225 plus x squared equals. Now, I would use a calculator. 18 squared is 324. So again, subtract 225 from each side. You get 99. So x is equal to the square root of 99. If you write it in radical form, we'll write the answer up here. We would have x is equal to 3 square roots of 11. All right, you have 2 types of special right triangles. The first one is called the 30, 60, 90 right triangle. Notice that if you add those numbers up, you get 180. The side across from the 30 degrees is known as x. The side opposite the 60 is x squared roots of 3, and the hypotenuse is 2x. So if I look at this, I know the x and y are going to be different. So in this case, if the 60 is the upper angle, the angle with the x-axis would be 30. So that would tell you x is equal to 12 in this case. So y is equal to 12 square roots of 3. And x would equal to 2 times 12, which is 24. Hey, because you're given across from the 60 degrees. So instead of x, let me go back and call that, let's call it a. Still the relationship holds the same. So here, a root 3 is equal to 9 root 3. Because if you look across from the 60, the side is 9 root 3. So if you divide by the root 3, or radical 3, a is equal to 9. That means across from the 30 is 9. So in this case, we're going to say x is equal to 9. Y is equal to 2 times 9. That's the hypotenuse. y is equal to 18. And if I do a squared plus b squared equals c squared, so this one here, if we do 9 square root of 3 times 9 square root of 3, we get 243 plus 81, 9 squared, is 324. If you do the square root of 324, you get 18. Or you could check it by going 18 times 18. Then we have the 45-45 triangle. Notice these sides are equal, making it isosceles. And the two sides that make up the right angle are the same length, so they're expressed as x. The hypotenuse is x square roots of 2. So looking here in number 4, I know that these sides are equal. So x is equal to 8, and then y is equal to 8 square root of 2. On the next one for number 4, we know that the hypotenuse is x squared to 2. See, that's opposite of 45. So we can say x squared to 2 is equal to 15 squared root of 2. And again, we're going to divide by the square root of 2. So x is equal to 15. Now, y is the same, so y is also equal to 15. And so there are some examples of special right triangles. Have a great day.